Okay, good morning, everybody. It is the 28th of May. We are almost done. Think about this. We got a couple of days this week. We got next week, and after that, we're done. And so then, if we're done, we got to get ourselves caught up because some of you are behind. So get yourself caught up. If you haven't finished or sent me chapter 10, you got to get that to me too. Those are going to go in the grade book today. And then I'll start calling parents if you don't have this stuff done. So get it done, okay? So let's look at last night's homework chapter. It's like 12-2, and on 12-2, let's see, these are my answers that I got from. So first of all, on the first one, you just say all the corresponding parts, how they're all, which all the angles are congruent. We just say all the sides are congruent. So the same thing on this one, I say all the angles that are congruent go to correspond, and all the sides that are congruent, they correspond, okay? And number 3, I set up I didn't show the work, but I set up the ratios, and I set up the correspondence, and then I got x is 25 and y is 2. 4, I set up the same thing where I've set up all the congruent sides. I go for x first, and then I can go ahead and set up, I got x is 6 and y is 10. And then on 5, what I do is the reason they're equal, okay? So, and we have to know this because this is part of today's lesson. So what I need is a few things. I've got the sides are equal, I've got the sides are equal, angle equal, so then I know 90 degrees, those two are equal. And also then if I know angle, and I got this angle, then I can say this third angle has to be equal. So this angle's equal to that angle by the third angle, and then I've got enough, okay? Same thing here, all the corresponding parts are equal, everything's, and so you can say obviously those are congruent. In 7a, obviously goes to this angle D, so 33 degrees. And on 8, when you go ahead and solve the triangle from 180, this turns out to be 46 degrees here, so therefore angle 1 has to be 46 degrees also because they're corresponding angles, okay? All right, now, today, let's take a look at the next section, 12.3, okay? So, we're going to talk about this thing called SAS. What the heck? SAS stands for side, angle, side. So what we want to do today is prove that two triangles are congruent. Because if they're congruent, then we can say all their parts, their corresponding parts, are also congruent, okay? So the first one they give us is SAS. All you need quite often is 3 things. We'll say things. What are 3 things? Well, triangles are made up of sides and angles. Well, we're going to start off today with a thing called side, angle, side. So I drew a picture, okay? So take a look at this. So I drew a picture and I used my ruler. I drew 4 centimeters here. I used my protractor and got 50 degrees here. And I drew this side to be 5 centimeters, okay? By doing that, there's only one triangle that's possible. Now, I didn't draw the triangle, but if I were to take and draw in the triangle, connect the dots, there's my triangle, okay? So let's call this triangle A, B, C. Now, if I do the same thing over here, and again, I use my protractor I use my ruler 4 centimeters, my protractor 50 degrees, and I drew this side as 5 centimeters. Again, there is only one triangle that can be drawn, and that's right there, okay? Let's call this triangle D, E, F. Well, there's no doubt if I look at that these 2 triangles have to be equal, okay? I can measure the length of this if I needed to, but of course it's going to be equal to that one too. It looks like it's about 4, and it looks like it's sure enough 4, okay? So if you have these 3 things, if you have a side, an angle, and a side, now be careful. See the A, S, A, S, so the angle you know has to be in between the 2 sides. Side, angle, side. I got side, angle, side. So it's what we call an inclusive angle, because the angle we know is in between the 2 known sides. If you know that, if you've got a side equal to a side, inclusive angle to an inclusive angle, another side to another side, if you have those 3 things, a side to a side, an angle to an angle, and a side to a side, then you can say that the 2 triangles are congruent. So I'm going to say this triangle ABC is congruent, means the exact same size, exact same shape. Triangle ABC is congruent to triangle DEF. And we're going to say by So the two triangles are congruent by, side, angle, side. And I don't mind the abbreviation because SAS in this class means side, angle, side. Okay? So now what we want to do today is be able to show that two triangles are congruent. So we do this thing called a proof. Okay? So it's a two-column proof. So we're going to stretch your brains a little bit today, but that's good. Okay? So let's go into our lesson. Okay? We're going to do two-column proof. So let's take a look at this. I have two triangles. I have triangle A, B, D. Okay. I like to color things. Okay. And I have triangle C, B, D. Okay. And of course I have a big triangle as well. But what I really want to do is show that these two triangles are congruent. Okay. But I have to have more information. So what I have is D is the midpoint of AC. So D is the midpoint of AC. Well, I know a couple of things. That means that this side is the midpoint. I know this side here has to be equal to this side here. Okay? It has to be if it's midpoint. Okay? And I also know that if it's perpendicular, BD is perpendicular AC, then I've got 90-degree angles on both sides. Okay? So what I need to do is this. I've got a theorem called side angle side. And if I can prove a side to a side, an angle to an angle, and another side to another side, I can prove the two triangles are congruent. Okay, so use your brains. We're going to stretch it out. We're going to talk about a proof today. Okay, so step one. What do we know? Okay, what do I know? I probably know that I can say that AD is going to be congruent to DC. I know that because of this whole midpoint thing, and I know these are going to be 90. Okay, so that's what I also know, that angle BDA and angle BDC are both going to be 90 degrees. Okay, so let's go through it. What can we see in the figure? Mark the figure. Well, I've got this side up at the 90, so mark the figure, and we're looking for three things. Remember, we're looking for three things. When I say things, we're talking about angles and sides. Okay, so I got one side to one side, I got an angle to an angle, and the third thing will be this side right here because they share that side. Okay, so let's do what we call a proof. Here is how a two-column proof starts. Statements, reasons. Okay, this is a formal proof. We do this in math. We do formal proofs in math. When you get up into calculus and beyond, you'll be doing formal proofs. Okay, draw a line because I'm going to put statements here, reasons. So the first thing I want to do is put down what I know. Okay, so what I know is this. I know that D, that's what I'm given. Okay, D is midpoint of AC. Okay, I know that. What else do I know? I know that BD is perpendicular to AC. All right, so I like to pretend it's like we're the big fancy attorneys. We're going to prove a case. So this is what we're given. This is our evidence. Okay, so we know we're given this, and the reason is because it's given. Okay, it's part of our evidence. Now, as smart people, how are we going to figure this out? Well, second step is I'm going to say that obviously if I've got a midpoint here, I'm going to say that AD is congruent to DC. Okay, I need three things. Okay, I need three things. So I know that. What's the reason for that? Well, it's because it's a midpoint. So I'm just going to say, well, because the definition of a midpoint. I can write that down. I need three things. I've got one. I've got this side equal to this side. I've got one thing. Okay. Okay. I can also say that I know that angle BDA is congruent to angle BDC. Reason for that? Because they're perpendicular. Okay. Perpendicular lines. I'm going to say perpendicular lines make right angles, right? Perpendicular lines make 90 degrees. Perpendicular lines make right angles. Okay, and I know if they're right angles, they have to be equal. Okay, Great. What else do I know? Well, if I take a look at this, they both share BD, right? So I'm going to say, well, if I take the triangles apart, BD is a different side. So I'm going to say step 4, I'll say BD is congruent to itself, BD. Okay? Now the reason for that, well, the reason for that we like to say is reflexive, but we're not going to get too fancy because this is just algebra. We're going to say that equals itself. Just say equals itself. Truly, though, the reason is this thing called reflexive property, okay, itself. You don't have to be perfect on this. You just have to give me some reason that makes sense. Okay. And finally, I've got the 3 things, right? Okay, let me mark my figure. Okay, the 3 things are this side, this angle, this side 2, this side, this angle, this side. So I can say I've got the 3 things. Once I have the 3 things, I can then say the triangles are congruent. So the last thing I'll say is 5. I'm going to say that triangle ABD, triangle ABD is congruent to triangle BDC. And the reason why? Well, by our theorem, our side angle side. If 2 sides of one triangle and an inclusive angle are equal to the 2 sides of another triangle and an inclusive angle, it is done. Okay, so we've proved it. That's a proof. Okay, let's take a look at it. Second proof, okay? Alright, so here's proof number 2. Alright, so what we do first is we write down our given, okay? That's what we always do. So first thing, whenever you do a proof, write down the given. What do we know? Well, M bisects AB and DC. What's the reason for that? It's given. So the first step is always put down the given. What do I know? What's my evidence? Well, my evidence is given right here. There's my evidence. Put it down, okay? Now, that tells me some things, okay? So if I know I've got a bisector, bisectors cut things in half. So second thing, let's go ahead and mark my figure. If that bisects AB and DC, then I can say that this side is equal to this side. So I'm going to say AM. It's got to be congruent to MB. And I've also got to say that DM, and let's say DM, is congruent to MC. Well, because it's bisected, that's obvious. So our reason is because it's bisected. I like to use definition of a bisector is what I'm going to write. Or anything like that. Even if you write just bisector, or if you write just the words, it's bisected. Good enough for me, okay? Use the keywords. Now I need 3 things, right? So I look at the figure. So then second thing is like, let's look at the figure, okay? Let's look at the figure. And again, we're looking for SAS, because that's our theorem, right? So what I notice is that vertical angles, that angle has to be equal to that angle. And that gives me my side angle side. So I look at the figure. So the figure itself gives me the third thing. Step 3, I know that angle AMD, can't say angle M, can't say angle M because that's really confusing. You have to say AMD, angle AMD is congruent to angle, same orientation, DMC. Okay, reason? Well, it's vertical angles. Vertical angles, okay? And then finally, I've got my 3 things. Okay, what am I trying to prove? That these 2 triangles are congruent. So step 4, I'm trying to say that triangle ADM is congruent to triangle BCM. And what's the reason? Well, it's from our side angle side. So we have side angle side to side angle side. So the reason is those 3 things, side angle side. Okay, that's a 2-column proof. They're kind of hard, they're kind of tricky. Homework today, and I'll walk you through it real quick, is page 336, 1 to 5. So let's take a look at that. 336. All I want to do is just try, okay? And if you're completely confused on proofs, just try. Just write down some things, and we can probably take it, okay? 336. So what I would do on number 1, perpendicular, I'd go straight to those 2 are 90. Okay, if you look at the figure, they automatically tell me these 2 are equal. Okay, Third thing, probably this side BD is equal to BD. Okay, and then you got your side angle side. 3, the two triangles we're looking for is J and K. J and K, that's that triangle here. And we're looking for this triangle here. Okay, so we're given these two are equal, these two equal. So the third thing I'd go for is the vertical angles. Okay, you can put that down. Here's your given, proof by side angle side. 3, you don't have to do a proof. You just have to say why you think they're equal. You've got this to this. And what I know, I automatically know this side has to be equal to this side because they're radii of a circle. And this side's got to be equal to this side because they're radii of a circle. Okay, side angle side. Okay, and then finally on 4, I can probably say this triangle here is going to be equal to this triangle here. Okay. And I can probably say that because I've got in a hexagon, I know if it's a regular hexagon, I know this side's equal to this side, right? And I know I've got vertical angles. Okay. Anyway, I'll let you work on that today. Try your best. Do your best, okay?